Alright everybody, hopefully you guys are doing good. Today we're solving Unit 2.1 Independent Study Packet, and it's going to be very fun. So, some things I will say before we get started. First, a lot of the things we're doing here are very gear focused and very math focused. Really what we're doing is we're finding what we're given, and we're picking an equation and then using algebra to solve that equation. The reason why it's physics and not math is because, well, right now in physics there's real-world applications to this. So let's get into those real-world applications with the first problem. A car initially traveling east with a speed of 5 meters per second is accelerated uniformly at 2 meters per second squared east for 10 seconds along a straight line. During this 10-second interval, how far did the car travel? Right, so what we're going to do first is I'm just going to underline what we're given, right? So here we're given 5 meters per second speed initially, okay? Because it says initially traveling with a speed of 5 meters per second. So that is initial velocity or speed. But then it accelerates at 2 meters per second squared east for 10 seconds. So what do we have there? We have the acceleration, and then we have 10 seconds of that acceleration. So we do time, and then during that 10-second interval, that's time again, right? How far? And how far is also something important because how far is what are we trying to find? So we're trying to find, what is it? It is displacement. How far? So we can set up our table. So let's set it up. What's the initial velocity? Initial velocity, 5 meters per second. We have it right up there. 5 meters per second. Accelerated uniformly at 2 meters per second squared. So acceleration equals 2 meters per second squared. And then 10 seconds, time is 10 seconds. But then final velocity, right? We don't know anything about final velocity. This says nothing about finding final velocity, and it doesn't give us the final velocity. So we can almost ignore final velocity for this problem. So final velocity, you can write, that's not applicable. And then you finally have displacement, distance. And what's that? How far did the car travel? So we're trying to find that. So let's go ahead and label that as the G for gear. Now what's important is that we pick an equation. So remember there's 3 equations, these kinematic equations that we're going to use. Here they are. We have the final velocity is equal to the initial velocity plus acceleration times time. So that's our first equation. Second equation, it's like a library of equations we have, and we have to pick the right one, right? Displacement equals initial velocity times time plus 1/2 of acceleration times time squared. And then the third equation is final velocity squared equals the initial velocity squared plus 2 times the acceleration times displacement. And what I will say is on your exam, you're going to get a reference guide that has these equations. So don't worry about memorizing them. Just we're going to learn how to find the right equation to use. And here's how we do that. So you'll see over here in our equation area, in our what we're given area, we're trying to find displacement. So we want to use one of the equations that has displacement. Okay, and then that lets us cross out the other ones. So which one does not have displacement? Well, 1 has no displacement, so why would we use 1? we can cross out 1 because there's no reason we would want to use 1. So for this, let's say no 1. We're not going to use that. Now, the second one does have displacement, so we could use that one maybe. The third one also is displacement. So how do we differentiate those two? So what we can do is, well, we don't know what the final velocity is. We're not given anything about it. So if you look right here, that's final velocity. Our question here gives us nothing about final velocity. So we don't want to use the equation that is final velocity either. So which of these two equations here does not include final velocity? This one. That's how we know we're going to use this one, because it includes what we're trying to find, and it doesn't include what we don't know. Right? And all we're going to do is we're going to expand it over here. So for the equation, always use gear. It's displacement equals the initial velocity times time plus 1/2 acceleration times squared. Great, and now let's go to the A. All we're doing is we're going to plug in the values, and it's just algebra. So we plug in, and velocity initial, what's the initial velocity? Right, it's right here. We have the initial velocity right here. And so we're going to replace that with this. We're just substituting. So the initial velocity is 5 meters per second. So we can do 5 meters per second. And then what's time? Time is 10 seconds. Have that right here. Oh, right there, we have time. And we're just going to plug in that time right here. Oh, and there. There's two places we're plugging in time. So we're going to plug in time, and the time is 10 seconds. That goes there. Then plus, we're just plugging in, plus 1/2, and then AT squared. So what's A? A is 2 meters per second squared. And what's T? T is 10 seconds. And then that's squared. Right, so now we just have to solve using algebra. And so let's do this first section here. This first section becomes, well, D equals, what's 5 times 10? That's 50, so 50. And then we also have to multiply the units as well. That's really important. So what is seconds, meters per second, times seconds? These cancel out here, and so we get meters. And I just want to make sure you really understand that, because we're multiplying 5 times 10, but we're also multiplying the meters per second times the seconds. And so this cancels out with that. You could also think about it like it's meters per second times seconds. And then I think that'll make it more clear how you can cancel these out. Okay, let's go back. So 50 meters, then we can continue with the rest of it. Plus, all right, so now let's do this side. Well, what is 1/2 times 2? We're doing this part here. 1/2 times 2 is just 1. And since this doesn't have a unit, these units stay the same. So this brings us to 1 meters per second squared times, we gotta bring this down here, 10 seconds squared. And what's 10 squared? 100. But remember, you also have to square the units. And so we're working with seconds squared. And so that is just, well, seconds squared. Great. And now, what's 1 meter per second squared times 100 seconds squared? Well, what is 1 times 100? Just 100. And then what is, so 1 times 100, that's going to give us 100. But then what's meter per second squared times second squared? We also have to do the units here. So you can look at it like this, meters over seconds squared times seconds squared. Remember, these just cancel out, and that gives us meters. And then what is it? This becomes 50 meters plus 100 meters. And that should make sense that we get meters because we're trying to find displacement, and displacement is always in meters. Usually in science, it's in meters. So we can circle that answer. Great. Next question. The speed of a car increases from 2.5 meters per second to 9 meters per second in 3 seconds as it accelerates uniformly downhill. What is the magnitude of the acceleration of the wagon during this 3-second interval? So here we're just doing the same thing. We can go a little bit faster since we already know what to do. G. Let's make our box. Initial velocity, final velocity, displacement, acceleration, and time. So, what's the initial velocity? Well, it says increases from 2.5 meters per second. So, from means initial velocity, right? So, 2.5 meters per second to 9 meters per second. That tells us that that's the final velocity, 9 meters per second. In how many seconds? 3 seconds. So it's accelerating as it accelerates uniformly down a hill. We're trying to find the acceleration. It says, what is the magnitude of the acceleration? And so right here, acceleration is what we're trying to find. Does it say anything about displacement? Nope, nothing in the question, so not applicable. So we also have to pick an equation. Let's go back to these equations up here. Which of these equations includes what we're trying to find, A, acceleration, but doesn't include D, what we don't know? Let's look. It's pretty clear. The first one includes A, but doesn't include D. So let's take that one down. The final velocity equals the initial velocity plus acceleration times time. So this is a crucial step what we're about to do. What you need to think about is, how do I make this in terms of what I'm trying to find? So we want to make it A equals, and then the rest of the equation. We want to solve for A. How do we do that? Well, this is also just algebra. We subtract VI on both sides, and that gets us VF minus VI equals AT, and then we divide by T on both sides. Divide by T on both sides, and then this crosses out here. That means A, acceleration, equals the final velocity minus the initial velocity over time. And we've already seen that in Unit 1. See, we're going to keep using these equations that we used in Unit 1, for example, for the bowling ball lab. Good. So now we can solve by plugging in our values. So the acceleration equals, what's the final velocity? 9 meters per second. What's our initial velocity? 2.5 meters per second. over, what's the time? The time is 3 seconds. And we just simplify the numerator. 9 minus 2.5 is 6.5. meters per second over 3 seconds. And then we can just divide. What's 6.5 over 3? 6.5 over 3 is 2.17. But we have to don't forget about the units. For the units, it's meters per second over seconds. And that becomes the same thing, just written differently as meters per second squared. And then again, that should really make sense because we're trying to find acceleration. And acceleration is in meters per second squared. Great. Next, we're just doing the same thing. G. A skater increases her speed uniformly from 2 meters per second to 7 meters per second over a distance of 12 meters. The magnitude of her acceleration as she travels those 12 meters is what? Good. So we have our box here. Initial velocity, final velocity, displacement, acceleration, and time. What's the initial velocity? From 7 meters per second from 2 meters per second to 7 meters per second. So initial is 2 meters per second, and final is 7 meters per second. And what's the distance? 12 meters. Acceleration, that's what we're trying to find. And we know nothing about time. So let's pick an equation from our library. We have 3 equations. What don't we know? We don't know anything about time. So we don't want to use any of the equations that include time. And which equation doesn't include time? Number 3. So let's write that down. For the equation, we have the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement. This equation confuses a lot of people because of the algebra. Remember, there's squaring. You have to square things. But before we do anything, remember we have to solve for acceleration. And so we have to put it, acceleration equals what? What is that? Well, we subtract VI squared on both sides, which makes it velocity final squared minus velocity initial squared equals 2AD. And then we can divide by 2D on both sides. And that leaves us with A. So our equation is acceleration equals the velocity final squared minus the initial velocity squared divided by 2D. Let's bring that up here and solve. Acceleration is equal to, what's the final velocity? 7 meters per second, so 7 meters per second. This is really important. The squared goes outside because it's meters per second and the whole velocity is being squared. I'll show you why that's really important later. Minus the initial velocity, which is 2 meters per second. And that's all going to get squared, divided by 2D. D is 12, So we can put 2d as 24. I just want to make sure you understand why. D right here is 12 meters. So 2d is 24 meters. So now for the next part. Well, let's simplify. What's 7 squared? 7 squared is 49. So we're going to have 49, but then what are the units going to be? This is really the tricky part, is the units. You might think it's meters per second squared, but this squared is going to the seconds and it's going to the meters. So in reality, it's meters squared per second squared. Minus, what's 2 squared? 4. And then again, it is meters squared per second squared. Because this squared applies to the 2, the meter, and the seconds. And that is over, again, 24 meters. And what's 49 minus 4? That's 45. And so that becomes, the acceleration is 45 meters squared per second squared over 24 meters. And so, what is 45 divided by 24? 45 divided by 24 is 1.9. And so that becomes 1.9. But then what's meters squared per second squared over meters? Right? Meters squared per second squared over meters. That meters is going to cancel out the squared for that meters, and I'll just write that down over here so you understand a little bit better. What we're doing for the units, we're doing meters squared over seconds squared divided by meters. And so this cancels out with that, and we get meters per second squared. Good, 1.9 meters per second squared. And you also know that because we're solving for acceleration, and acceleration is in meters per second squared. So getting the right units is a good sign that you got the answer right. Okay, 2 more. So, what are we given? You should be getting the hang of it now. We're given that what is the final speed? So we're trying to find final speed. Starts from rest. Starts from rest is something you'll see a lot. And how many meters per second is rest if it's not moving? 0 meters per second. So 0 meters per second. It accelerates at 4 meters per second squared. So 4 meters per second squared over a distance of 8 meters. And we don't know anything about t, so not applicable. And which one are we going to use? Which one doesn't use t? That's what we just did. So we're using the same equation as we just did. And we just already went over how to change it in terms of acceleration. Now we're trying to find the final velocity. And what is good is that it was already in terms of final velocity squared. So that's going to make it so you don't have to do as much work. So final velocity squared equals the initial velocity squared plus 2 times the acceleration times the displacement, or distance in this case. So let's plug in our values. What's the initial velocity? Initial velocity is 0 meters per second. And what's that squared though? We're going to do that soon. Plus 2 times the acceleration times the distance. 2 times, what's the acceleration? acceleration is 4 meters per second squared. Meters per second squared. And then what's the displacement? 8 meters. Let's bring that down. 0 meters per second squared. Well, this becomes 0 meters squared per second squared. Plus, what's 2 times 4 times 8? We're doing this part here. 2 times 4 times 8 is 8 times 8, 64. And then what are the units? Well, we're doing meters times meters per second squared. And what's meters times meters per second squared? That's meters squared per second squared. And so, notice, but you gotta be careful, we have final velocity squared on the left, and we're trying to find velocity. But let's first simplify the right-hand side. What's 0? Since they're the same units, you can just add them, add the numbers. So 0 plus 64 is 64. So basically, this has no meaning. And then, how do we get to final velocity instead of final velocity squared? We can square root both sides. And we also, just like when we square, we do the units, we also, when we square root, we do the same. And so this becomes the final velocity equals, well, what's the square root of 64? 8. And then what's the square root of meters squared per second squared? Right? That's meters per second. Good. Answer, 8 meters per second. Last problem. If a car accelerates uniformly from rest to 15 meters per second over a distance of 100 meters, the magnitude of the car's acceleration is what? Okay. Let's make the same thing. Do the G. Well, if a car accelerates from rest, so we know the initial velocity is 0 meters per second to 15 meters per second over a distance of 100 meters. The magnitude of the car's acceleration is what? So we're trying to find acceleration. We don't know time. So isn't that funny? We're going to use the same equation. So we've used the same equation 3 times in a row. And we're trying to find acceleration. And remember, we already did this up here to make it in terms of acceleration, solving for acceleration. So we can reuse that, right? You already did the hard work. Acceleration, lowercase a, equals the final velocity squared minus the initial velocity squared divided by 2d. Let's plug in the values. Acceleration equals, what's the final velocity? 15 meters per second minus 0 meters per second squared divided by 2d. What's d? D is 100 meters, so 2d would be 200 meters. All right, let's just simplify. So what's 15 squared? 15 squared is 225. And so that becomes acceleration equals 225. And what are the units going to be? Remember, the squared applies to the seconds and the meters and the number. So meters squared per second squared minus, well, this is just 0, so we don't have to worry about that. What we do know, though, is that it's going to become meters squared per second squared, and so that's why we can subtract 15 from 0, which just gets us 15. Or when we square it, 225. So 225 meters squared per second squared over 200 meters. And remember, the units are important, so this cancels out with that. And so that's why we get meters per second squared. And again, we're trying to find acceleration, so it makes sense. What's 225 over 200? 1.13. Great. Good. We solved it. Okay. That was a good one, guys. Remember, this was just a lot of algebra, mostly finding the equation you want to use, reading the problem well, and then using algebra to solve the equation. Great.